Good morning, second hour. Happy Halloween. You should be on page 16 of your Unit 5 packet. We are going to discuss how can I apply the Pythagorean theorem to other types of triangles. So yesterday we just did right triangles. I want you to take a second, pause the video, and try this warm-up right now with your team. It should not take you more than 3 minutes. This is review from yesterday. Pause. Hopefully you set up your equations like this. Remember yesterday we really focused on highlighting the hypotenuse. The hypotenuse is always the longest side, and it's across from the 90-degree angle. From there, you should have gotten C is 5, and then you should have gotten A is 3. Please check your work. This is, again, a warm-up review of what we did yesterday. Now on to our investigation. Does this pattern hold up for acute and obtuse triangles? So I've got an example of an acute triangle. I've got an example of an obtuse triangle. And I want you guys to find the area of each of the squares just like we did yesterday. Again, the area would be 4 times 4, so this area is 16. This is a 5 by 5 square, so this area is 25. This square is 4.5 by 4.5, so you might need a calculator. It's going to be 20.25. Again, try that for the obtuse triangle. You can pause the video, and you and your team can find the area of the obtuse triangle squares. Take a minute to do that. Please check your work. Again, we're looking for patterns like we did yesterday. Yesterday we noticed the two short or the two legs of this triangle added up to be the hypotenuse area. And today we don't have legs or the hypotenuse because we're looking at an acute triangle. We're looking at an obtuse triangle. So we're going to go by the shortest and the shortest compared to that longest side. Let's fill out the table now. So in our acute triangle, one of the short sides is 4, and its area, so the side is 4. The area for that was 16. The other short side was 4.5. The area for that was 20.25. We're going to add these two things together. Add these two areas together. We should get 36.25. And again, for the longest side was 5 units. And that area for that square was 25. What could we say about this relationship? Is it greater than, less than, or equal to? Hopefully you're noticing it's greater than. Let's fill out the table. For the obtuse triangle, one of the short sides is 5 with an area of 25. One of the short sides is 9 with an area of 81. We're going to add those two together. 25 plus 81, we get 106. The area for the longest side was 169. How can we compare these two areas? Hopefully you're saying that 106 is less than 169. All right, we're going to move to the next page where we're going to make some conclusions about our observations here. So will you flip to this page, please? So what's happening is if the sum of the squares of the two smaller sides of a triangle is smaller than the square of the longest side, then the triangle is going to be obtuse. Obtuse. this means a squared plus b squared is going to be less than c squared. Our second option is if the sum of the squares of the two smaller sides of the triangle is larger than the square of the longest side, then the triangle is going to be acute. So again, this means if a squared plus b squared is greater than c squared, then your triangle is acute. Let's test this out now in our examples. This time, we're trying to decide, is it right, acute, or obtuse? And your options are less than, greater than, or equal to. So you're going to start by squaring each of these sides. We're going to add the two shorter ones together and then do a comparison. What's our comparison going to be? Hopefully you're saying that 13 is less than 16, which if I go back up here, is going to give me an obtuse triangle. Let's look at the next example. If you need to pause the video, please do so. For our next example, again, we're looking at a 3 squared plus 4 squared. How is it related to 5 squared? We get 9. We get 16. We get 25 for the largest area. Now again, we're combining these two and we're doing a comparison at the end. 25 equals 25, which goes back to our lesson from yesterday. So this must make a right triangle. Please pause the video and try that last example with your group. This last example, this should have been 4 squared plus 5 squared. We're not sure how it relates to 6 squared. And when I add my two shorter sides, those areas, we get 41 is greater than 36, which means we're going to get an acute triangle. We're going to stop here for today. Tomorrow, we'll check out some of these examples together, answer any questions you have. You do not have homework for this lesson, but you do have these practice examples on a worksheet. This is just reviewing Pythagorean theorem, what we did yesterday. So again, you're just using a squared plus b squared equals c squared. Please complete this worksheet with your group. We'll discuss questions tomorrow. Thanks, guys. Have a great day.